Hello everyone, am I audible?
Yes, sir.
Okay. Hello everyone, happy Diwali. Uh, mm, just yeah, these are the properties of definite integration, and we would be talking about these properties as well as we will be on the last exercise of our integration. So we will complete integration today. But before that, I would like to ask if you face any problem in exercise 7.9 and exercise 7.10, then this is the right time to ask your doubts. We will proceed only after we clear your doubts. So if any problem faced by you guys in the previous two exercises, you can ask that. The previous two exercises were based on definite integration. So we first talked about how to evaluate definite integration. So no big deal. We just have to put the limits. You start the question using indefinite integral only. So you first integrate the function, and then after you get the answer, you just put upper limit and lower limit in that, and we know how to solve that. Right? And then second exercise was based on substitution, in which we have already studied substitution, right? But in the case of definite integration, we can also, while we substitute, we can also change the limits, right? So it is always advised to change the limits so that you can save some of your steps and the calculation will be fast, right? So I've discussed these two things, which were nothing new, actually. We just only understood the concept of limits in the last class. That how is definite integration different than indefinite integration? Definite integration uses limits, upper limit and lower limit, right? And we can solve these limits very easily. So please feel free to send me your doubts. You can tell me the question number if you face if you face problems in any question. You have 1 minute. Please feel free to reach out. No, Tarif, this today we will be starting exercise 7.11. I have given you homework 7.9 and 7.10 in the last class. So 7.10 exercise is based on substitution, indefinite integration. But yes, you can ask your doubts from any exercise. In the last class, we have given you 7.9 and 7.10. And if you have problems from previous exercises, no worries, you can ask that. But today we will be starting 7.11. Okay, so I'm assuming no one has faced problem in any question, right? Okay, then let's start with uh, this last exercise of integration. And so before we start this, two things. One is that there are high chances that if a question comes from definite integration, which will definitely come in the exam. So if a question is from definite integration, most probably that question will be from this exercise, because you can easily see that 7.9 and 7.10 exercises were pretty basic. No, we didn't do something new. We already know how to calculate indefinite integration. We just have to put the limits. And in 7.10, we already know how to substitute, how to apply substitution and integration. We just have to change the limits as well, right? So these two are pretty basic exercises. So they won't give you question from those exercises. The question will be from this exercise. So this is the most important exercise from definite integration. If you solve the whole exercise, you are getting those 4 marks. Believe me. Okay. Yeah. So now, as I said that we didn't do anything new in the previous two exercises, but this exercise is new. Now, what are we studying? We are studying the basic properties of definite integration. So in this exercise, we would learn how to apply some properties of definite integration in solving the questions. Now, these are 8 properties, 8 basic properties. So let's first understand all of these properties and also start writing them. Okay. So I'll start with first. I would first tell you what are these properties, how to, just understand what have we written first. So the first property says that if you are integrating some just give me a minute. I think somebody has joined. Pfizer, yeah. Yes. So, hi Pfizer. We have just started. Uh, we are on exercise 7.11 from definite integration. This is the most important exercise in definite integration. So we were discussing properties and I have just started. So let's start understanding the properties of definite integration. So the first property is if we are integrating some function fx, right, with respect to dx from the limits a to b, right, then if I change the variable from x to anything, the all, see, okay, let's understand it with an example. So for example, what we are saying is, let's say you are integrating x square with respect to dx from the limit 2 to 4. Okay. Now, if I say that I want to change x, I don't want my variable as x. I want my variable as t or y. Then it's okay. As long as the function that you are integrating, which is x square in the first case, and your variable of integration, these x square and dx, if the format remains same and the limits remain same, then the answer will be same. So what are we saying? That if you are integrating x square with respect to dx from the limits 2 to 4, right? And then you are integrating some other, uh, some function of other variable, let's say y. So now I am integrating y square with respect to dy from the limits 2 to 4, then the result will be same. So basically, we are saying that if I don't change my function, the function was square function, right? Here also we are squaring, here also we are squaring. So either I integrate x square with respect to dx, or I integrate y square with respect to dy, or I integrate t square with respect to dt. All are same as long as the limits remain same. So what we are saying here, as long as your function remains same, whatever was function fx, the same function is also here ft. Your f is same, that is your function is same. You have just changed your variable. You haven't done anything. You haven't really changed anything here. You have just changed your variable. So you have replaced x with y, simple, or x with t, or x with any other variable, whatever you want to use, z. As long as the function remains same, the limits remain same, the answer will be same. No worries. So the first property is very basic. You don't need to, this won't be even used. We are just telling you the concept, because every concept of this all of these 8 properties are important, because every property will teach you something. So we are using all of these properties in proving other properties, right? So first property says that as long as your function remains same, your limits remain same, you can change your variable directly, no worries, answer will be same. And I have given you an example of also. Now the second property says, if I'm integrating fx, right, from the limit a to b, then I can interchange my limits with a negative sign. Then I can interchange my limits with a negative sign. So I can write the limits b to a, but in that case, I have to apply a negative. And very basic, it's a very simple explanation for this. You know, the answer would be whatever the answer of this integration is. How would you calculate that answer? Finally, when you integrate this function fx, whatever you get, you will put b and a in that, right? So first you will put b minus upper limit minus lower limit, right? That is how we calculate. But in this case, we have changed this order, right? So I am doing lower limit minus upper limit. If I apply a negative sign outside, then it would be again upper limit minus lower limit, right? So I can interchange my limits. So what am I saying here is, so if I want to integrate x squared dx, right, from 2 to 4, then it would be equivalent of saying I want to integrate x squared dx from 4 to 2 with the negative sign. Both are same thing. That is what we are saying. So we can always interchange the limits of a definite integral, and when we exchange the limits, we just have to put a negative sign, right? Now the third property is also important, by the way. I have not put a star on this, but yes, this is definitely important. Now third property says that if you are integrating fx from a to b, right? So let's say I was integrating x square from 2 to 4. I will take the same example and I will do everything. Okay. I can take the same example and you can see. Okay, chalo. Let's make it more authentic. How can we do so? So let's take an example. So I want to integrate x square from 2 to 4. Chalo, pehle to let's integrate this. Okay. So this would be x cube by 3 from the limit 2 to 4. I can take 1 by 3 outside. This would be 4 cube minus 2 cube, right? 4 cube is 64, 2 cube is 8. 64 minus 8 would be 56. So this would be 56 by 3. So we know how to integrate x squared dx. Now you can yourself check first and second property. No worries. You can definitely check this. But I would start with third. Okay. Because important properties start from third. First and second are pretty basic. You will get that. If not, then you can ask me anytime. Okay. Yeah, so let's come to third property. Third property says that if I integrate x square, if I integrate a function from a limit to from a lower limit to an upper limit, then I can also break this limit. What does that mean? It means that I can integrate the same thing, x squared dx, first from 2 to 3 and then from 3 to 4. The answer will be same. It won't change. Or I can also write this. This is the third property, by the way. I can also write this as 2 to 2.5 wherever I want, guys. जो मैं चाहता हूं मैं कर सकता हूं, जहां पे मैं इसको ब्रेक करना चाहता हूं कर सकता हूं. And then 2.5 to 4, the answer will be same. You can actually calculate them. Please do verify them. Don't just believe me. Please verify them. Okay. So we can break the limit in between 2 to 4, and also not just in between, I can also write the same thing from 2 to 5 x squared dx plus 5 to 4 x squared dx. That is what third property says. That if you want to integrate some function from a to b, then you can break this into many parts, into jitna chaho utna parts. Okay, I would also like to explain this a little more. I can also write this as 2.5 to 3 then 3 to 4, or 3 to 3.5, then 3.5 to 4. I can break this limit in as many parts as I want, in as many parts as I want, right? So this is a very important property. This will come handy while solving some questions. But always remember that you can break the limit as many times as you want. I mean, we have to use these properties. So we will see how to use these properties in the questions. Hanji, now let's come to the fourth and the most important property among all. This will be used extensively. This will be used extensively. By the way, fourth and fifth are same. Fourth and fifth are same. Similarly, sixth and seventh are same. Now let's first discuss this. What is fourth property? Fourth and fifth are same. Okay. You understand fourth, you will understand fifth also. But first understand fourth. Okay, so fourth is saying that if I want to integrate a function fx from a to b, okay, if I want to integrate fx from a to b, right, then I can also transform my function fx, or rather than this, I can transform my x. I can transform my x. Okay, understand what are we doing here? Understand this. What are we doing here? We are just transforming x as a plus b minus x. Everything remains same. You just change your variable x to a plus b minus x, and the answer remains same. This is a very important property. This will be used extensively. This is the most used property in this all of these 8 properties, right? But a very simple explanation for fourth is that what are we doing? We are just replacing x with sum of lower and upper limits. So your lower limit was a, upper limit was b. Take the sum, which is a plus b, right? So you change your x with upper limit plus lower limit minus x, which is a plus b minus x. You can see in the fifth question also, you have done the same. We are changing our x to lower limit plus upper limit minus x. This is same, right? So fourth and fifth properties are same. It is just that they give this property differently, separately. So I have written this, but you don't need to take this as two properties. They are not two properties. This is just a single property, fourth and fifth. But yes, the important part is that we can always use this. And let's now check this, whether this is correct or not. So I have not solved these, but you can definitely solve them and verify them. But I will solve this because this is the most important property. And this we should know how to use. So we were calculating 2 to 4 x squared dx. We know the answer. The answer is 56/3, right? Now let's apply first of all fourth property. Fourth property says that if you are integrating a function from a to b, and then if you change the function mane, what is the function here? Function here is x square, right? If I change x square as, that is, if I change my x as first lower limit plus upper limit minus x, then also the answer remains same. That is, in place of x, if you write 6 minus x, in place of x, if you write 6 minus x whole square, then also the answer remains same. Now let's verify this, okay? Because I mean, we can easily verify this from here, and let's find out whether the property is correct or not. So we know how to integrate this. This is nothing but we have done a linear transformation in this case, right? And this linear transformation can be solved. Now, how to solve this? This is 6 minus x whole square, right? So we can write it as 6 minus x whole cube divided by 3, and also divided by the coefficient of x. Coefficient of x is what? Minus 1. So remember that we have applied a linear transformation. Linear transformation. And we know in case of linear transformation, we divide the whole answer by the coefficient of x. Coefficient of x in this case is minus 1. So I have divided the whole answer by minus 1. And now I want to integrate this from 2 to 4. Chalo, let's start putting this. I can take minus 3 outside, 1 upon minus 3. Let's put the values. So this is 4, 6 minus 4, which is 2 cube. Put x is equals to 2, this becomes 4 cube. 2 cube minus 4 cube is minus 56. And you can see that the answer is same. So as I said, going forward, this will be the most important property. This will be the most important property which will be used. That we can write, if we are integrating fx dx from the limit a to b, then this will be equivalent if you change x with a plus b, that is lower limit plus upper limit minus x. Then also the answer remains same. Now remember one thing. We have understood fourth and fifth is also same, right? Now remember one thing. Whenever you approach a question from definite integration, whenever, and you are not getting anything, I mean, you don't have any clue how to solve the question, then always apply this fourth property first. Always apply this fourth property. As I said, this will be the most used property of definite integration. And whenever you are in doubt, please always apply this property, because most of the times this will work out. Right? Now, sixth property says that if I'm integrating fx from 0 to 2a, now what is this 2a? 2a can be anything. For example, let's take an example. So if I'm integrating cos x dx, and let's say I
Sir,
want to integrate this from, yes.
sir, if possible, can you just scroll up?
Yes, I will, Shavis, but not right now. Give me a minute. I will scroll this
Okay,
up
sir.
when I explain seventh property. Okay. Yeah. So in the sixth property, we are saying that let's say I want to integrate cos x from 0 to pi. Okay. Then I can also write this as integrate the same function cos x from 0 to a. So let's take this as 2a. If this is 2a, then a is pi by 2. So I can write this integration of cos x dx from 0 to pi as integration of cos x from 0 to pi by 2. You can see this is 2a, this is 2a, then this is a, right? So I can integrate cos x dx from 0 to pi by 2, and with the same limits, 0 to pi by 2, I can integrate cos of 2a minus x. That is change x as 2a minus x. What is 2a here? Pi. So cos of pi minus x dx. This is the application of sixth part. Now, when to apply sixth part, we will discuss. It is an important property, but will not be used a lot. Although it is important, but it will not be used a lot. Now, as I said, seventh is also same. You can see the sixth and seventh are pretty simple. So we are saying that if this function f2a minus x is equal to fx, if this f2a minus x is equal to fx, then these both will add up and will become twice of 0 to a fx dx. And if this function f of 2a minus x is equal to f of minus times of fx, then this will be 0 because they will both cancelled out. So sixth and seventh are same. We are just saying, I mean, sixth and seventh are same if this conditions is satisfied. That is whatever function you are making, that is f of 2a minus x. Now the last property, eighth. Only used when your limit are in the form minus a to a. For example, I am integrating x square from minus 2 to 2. So whenever my limits are like this, minus 5 to 5, minus 10 to 10, minus 7 to 7, minus 100 to 100, anytime the limits are from minus a to a, then only this property can be used. So when my limits allow me to use this property, only I can only use this property in that case. Now let's understand what the property says. So if I'm integrating some function from minus a to a, then this can be directly integrated if my function follows any of the criteria. So if my function is even, then this can be written as 0, twice of 0 to a fx dx. And if my function is odd, then the answer is 0. Now let's understand what are even function and odd function. Do someone know about odd function and even function? Can somebody explain? Any one of you? Did we discuss even function, odd function in functions?
Sir,
If not, then we can, yeah, please.
sir, f of minus x is equal to minus fx, then it is odd.
That is correct. Give me an example. No, ये तो मैंने भी लिखा हुआ है शायद. मेरे को कोई एग्जांपल से समझा दे कि ये है इवन
That I
फंक्शन,
don't.
ये है ऑड फंक्शन. नहीं, ये कैसे चलेगी? अच्छा चलो, एक्स स्क्वायर. ओके, एक्स स्क्वायर इज एन इवन फंक्शन. व्हाई? See, these are two important properties. I mean, these are two kind of functions only, even function and odd function. Now I have written what is even function and what is odd function, but let's understand what is an even function and what is an odd function. So first understand theoretically, okay? Then we will discuss this practically also, but first understand it theoretically. So what is an even function? All the functions are even, all those functions in which if you exchange x with minus x, if you exchange x with minus x and the function does not change. For example, x square, you replace x with minus x and function will still be x square, right? Okay, or thoda basic, let's start with more basic. X square, if I calculate the value of x square at 2 or minus 2, both will be same. 4 minus 4, both will be same. 4 square is also 16, minus 4 square is also 16. All those functions in which if you replace x with minus x and the function does not change. See, that is what I have written. If fx and f of minus x both are same, then the function is even. X square is an even function. X to the power 4 is an even function. X to the power 6 is an even function. Cos x is also an even function because cos की value 60 पे भी cos 60 and cos of minus 60 both are same. Cos does not change when you replace an angle with its negative part. No, the answer is same. So let's write this here. What is an even function and odd function? See, fx, let's say your function is x square, right? Now you replace x with minus x. So function will become minus of x ka whole square. But what is this minus of x ka whole square? This is again x square. So this is an even function, right? Cos x is also an even function. And also remember that all the even functions are symmetrical about y-axis. That is, the graph will be same in the right hand side of y-axis as well as the left hand side of y-axis. Both will be mirror image of each other. For example, let's take the graph of x square. So x square का graph होता है this, right? Now these take this y-axis as the mirror. If this is the mirror, then both of them are mirror images of each other. So if this is the mirror, the image of right hand side part will be this. This is the mirror image of right hand side part. If you take y-axis as a mirror. Right? So this is what we call even function. And let's discuss odd function also. Odd function are those functions in which if you replace x with minus x, then the function becomes negative time of itself. Function becomes it is also chalo, let's come to that afterwards. Let's take some example. For example, fx is equals to x. If you replace x with minus x, then your function is minus times of the original function. Your original function was x. So if you replace x with minus x, in this case, your function becomes negative times of itself. Okay, let's take one more example, x cube. Now, in case of x cube, if you write f of minus x, then it becomes minus x ka whole cube, right? Which becomes minus of x, because minus cube is minus, x cube is x cube, right? What was x cube? X cube was our original function. So you can see in all these cases, one more example, sin x, tan x. all of these are known as odd function because they becomes negative times of itself when you replace x with minus x. When you replace x with minus x, then they become negative times of itself. All such functions are odd functions. By the way, generally, I mean, not generally, all the odd functions are, I mean, compulsorily, all the odd functions are symmetrical about origin. Symmetrical about origin mane, the graph which will be in first quadrant is a mirror image of third quadrant, and the graph which is in second quadrant will be a mirror image of fourth quadrant. So whatever graph is in first quadrant, the same graph will reflect in third quadrant, and whatever graph is in the second quadrant, the same graph will be fourth quadrant. For example, let's take the graph of x cube. So the graph of x cube is something like this. Something like this. So if you take this, then the graph will be symmetrical about origin. Whatever is the graph in first quadrant, the same graph is in third quadrant. So if your function is either odd or even, then you can directly solve the limits minus a to a wala questions. But it is not mandatory that your function has to be either odd or even. Your function can be neither odd nor even. So it is not necessary that the function has to be either odd or even. It may be possible that function na odd ho na even ho. Definitely possible, right? Tharif, the graph is, you can see it like that. Okay, put a mirror here. Put a mirror here. Okay, if you put a mirror on origin, then the graph in first quadrant is a mirror image of the graph in third quadrant. Both of these are mirror image. So this is a property of odd functions, that the graph in first quadrant will be a reflection of the graph in third quadrant and vice versa. And obviously the graph in second quadrant will be the reflection of the graph in fourth quadrant. Although it is not, I mean, it is an important property, but will not be used in our case. I just wanted to give you this information. This is not, I mean, this will not come in your board exams. बोर्ड एग्जाम्स में तो बस हमें इतना ही पता होना चाहिए कि इवन फंक्शन क्या होता है और ऑड फंक्शन क्या होता है. हाउ टू चेक दिस? चेक करने के लिए वी रिप्लेस एक्स विद माइनस एक्स. इफ द फंक्शन चेंजेस to its negative times, then the function is odd. If the function does not change, then the function is even. And if the function shows any other sign, for example, let's take this. Okay, let's take one more case. Let's take one more case. Let's say our function is x square plus x. Okay. Now I want to check whether this function is odd or even. So what will I do? I will replace x with minus x. ठीक है जी. If you replace x with minus x, then your function will become f of minus x. Here it will be minus x whole square. Here it will be, okay, let's write this as x cube. Here it will be minus x whole cube. So this will be x square. This will be minus times of x cube, right? So when you replaced x with minus x, your function becomes x square minus x cube. The original function was x square plus x cube. You replaced x with minus x, the function became x square minus x cube. Now, is it the negative times of the original function? No, because the negative times of original function would have been minus x square minus x cube. And this is not the same. So you can see it is not equal to minus times of fx. It is not equal to fx also. Function changed, but function did not change in the way we wanted. We wanted either no change in the function. If no change in the function, then the function is even, but the function is clearly not even because the function has changed. But did function change into minus times of the original function? No. Minus times of the original function would have been minus x square minus x cube. But the function only changed in one term, not both the terms. Right? So this is neither nor even. Right? Let's come back. Yeah. So this is function is even, then you can write that function, remove your lower limit, minus a, change it to 0, and function is even. And if function is odd, don't even solve the question. Answer. You just have to prove that the function is odd. And how to prove that? I just told you. Anji, clear hai? Are these properties clear? Can we start with the questions? If you want to ask anything, please feel free to ask me. Don't hesitate. This is the right time to ask.
Sir,
Anji,
sir,
yes,
the
Shagas.
one you marked with the star are important.
Yeah, these are important. These will be used
Yes, sir.
extensively. So fourth, sixth, and eighth. These three properties, I would say, are really important. Fourth is the most important, but this will be used the most. Chalo, let's start with some questions now. The questions will give us a better idea how to use these properties. Understanding these properties is one thing, but using them in the question, in the application of solving questions is a different ball game altogether. Let's start with pretty basic examples first. And I'm going to integrate mod x from minus 3 to 1. I said a simple concept. Uh, second property can be used, but you know that this is not a very important property. I mean, very basic property that we can iterate the limits. वो तो कहीं भी लगा सकते हैं यार, उसमें तो कोई बात ही नहीं है, मतलब वो तो कोई प्रॉपर्टी है ही नहीं एक्चुअली। तो ऐसी एक छोटी सी प्रॉपर्टी है, हम लगाते रहेंगे कहीं भी। उसका तो मतलब गेम तो Let's start with the third property. Property says break the limit. Right? Limit A to B, then we can integrate from A to B, right?
Sir, your voice is lagging.
But first, why do we need it? Okay. Am I audible now? What, am I not audible? Hello. Would anybody tell me? Am I audible?
Yes, sir, you are.
Okay. Chalo. So let's start with why do we need third? भाई मतलब क्या है? क्यों तुम हमें इससे तोड़वा रहे हो लिमिट? क्या हम इसको डायरेक्टली इंटीग्रेट नहीं कर सकते? ऐसे ही नहीं कर सकते भाई. इसीलिए इसीलिए ब्रेक कर रहे हैं बस लिमिट्स, है ना? So the first point is to understand why are we breaking the limits? Why do we even need to break the limits? Right? So this is an important point which would we need to break the limits just a minute. Guys, just give me a minute. Just give me a minute. Yeah. So what? Yeah. So we need to break the limits. So the question is that why are we breaking the limits? We need to break the limits if whatever function you are integrating is a piecewise function. And I think we have already discussed piecewise function. Everybody knows what is a piecewise function or not? Piecewise functions are which are defined with multiple expressions, right? So in this case, we can't directly integrate mod x, right? We can integrate x or minus x. So because mod x is a piecewise function, so it is defined with multiple expressions. I mean two or more than two, right? You know how to define mod x? No? Mod x is either x or minus x, depending on the values of x. If x is greater than or equal to 0, you directly remove these bars. But if x is less than 0, then you remove these bars by taking a negative outside. So if it is minus 4 mod, then the answer is 4. This approach. And if it's 4 mod of 4, then the answer will be direct 4. Right? So because this is piecewise function, so third property. Now uses, please write all of this. Please don't forget. So the uses of third property is in case of piecewise functions. When your functions are piecewise, and the piecewise function, most probable function will be modulus. Most used function in your syllabus will be modulus, right? So whenever you face any piecewise function, you first define that function, and only then you will be able to integrate that function. Otherwise, you won't be. Okay. So I was trying to integrate mod x, but I know two expressions, either x or minus x. And where does it change? At 0, right? So I would break question into two parts now. I would first integrate from minus 3 to 0. That is for all the negative values. And for the negative values, the value of x is minus x. And then from 0 to 1, that is the positive value of x. In that case, the value of mod x will be x. Please try to understand this again if you not, if you did not. Why we need to break the limits? We need to break the limits because the function which we are integrating is piecewise. इसका क्या मतलब है? Piecewise function has many expressions. Right? Mod x cannot be defined with only one expression. Mod x has two different expressions. Either you remove the modulus directly, that is x, but in that case your x must be positive, or you remove the bars with a negative sign, minus x, when your x is negative, right? Now we need to first define this function mod x, then we will be able to know where to break the function. So we know that for all the negative values, this function is minus x, and for all the positive values, this function is x. So we have broken the limits as minus 3 to 0 and 0 to 1. So now you will get your answer. This is minus of x square by 2 from minus 3 to 0, plus this is by 2 from 0 to 1, right? So this will be 0, 0. Okay, you can take minus half outside. You can take minus half outside. This will be 0 square minus minus 3 square. And you can take half outside. This will be 1 square minus 2 square. So the final answer would be something like this is 9 by 2, okay, plus 1 by 2, 10 by 2, 5. So third property will be used in case of piecewise function. Important. Please feel free to ask your doubts. And if after this, then we will integrate this second function. Can we start? If somebody is writing, just raise your hand. If you want me to stop, then please raise your hand. Otherwise, I would start. Okay, ji. चलिए. Again, as soon as I saw a modulus, I know that this modulus of x square minus 1 can be written in two ways. Harif, let's start the second one. This is again the same. This is also the same. So as soon as I saw the modulus, I know that this modulus can either be written as directly x square minus 1, या तो मैं इसको directly ऐसे ही open कर दूं, or I can write this as minus times of x square minus 1. This is the way that we approach mod x. We already discussed this function, but I am very sure that you haven't practiced enough, so you won't be able to remember this. But let's again try. Okay. So whenever I solve a modulus, to solve a modulus has always two expressions. Either modulus directly removed like this. I have just removed the modulus. I just removed the bars. Or the modulus can be opened with a negative sign. This will be the answer if x square minus 1 is positive. And this will be the answer if x square minus 1 is negative. So remove the modulus if the quantity inside is positive. Remove the modulus with negative sign if the quantity inside is negative. Come again, please. Remove the modulus directly if the quantity inside is positive. Remove the modulus with negative sign if the quantity inside is negative. Right? Now, let's solve this. When will be x square minus 1 positive? For what values of x square minus 1 would be positive? So I can solve this. Be x greater than equal to 2, right? When will x square be greater than equal? Either x will be greater than equal to 1 or x is less than equal to minus 1. X is less than equal to minus 1, square will be greater than. You take x minus 2, its square is 4. You take x as minus 3, its square is 9. X minus 4, minus 5, its square is 16 or 25, right? So x square minus 1 is greater than equal to 0. Mane x square should be greater than equal to 1. Means that x either should be greater than equal to 1 or x must be less than equal to minus 1. Right? So if you got the answer for first, this above equation, then you also got the answer for the second equation. It means that x must be from minus 1 to 1. For x square minus 1 to be negative, x must be from minus 1 to 1. If x is greater than equal to 1, then it is positive. If x is less than equal to minus 1, then it is also positive. But if x is in between minus 1 to 1, then it is negative. This is the first step that we should understand. Only after this, we will be able to solve the question. So please feel free to ask me your doubts, because your doubts will be from this part only. और वैसे तो ये part हम already कर चुके हैं, but I know that this part won't be clear to you unless you have practiced enough. So please feel free to ask me your doubts, because this is the important part. अगर हम ये समझ जाएंगे तो आगे वाले पार्ट को तो समझने में कोई प्रॉब्लम ही नहीं. But first understand, we have to open the modulus function, because modulus function is piecewise. So you remove the modulus directly if the quantity inside is positive. You remove the modulus with a negative sign if the quantity inside is negative. So x square minus 1 modulus of x square minus 1 can either be x square minus 1 or minus times of x square minus 1. When will it be x square minus 1? When x square minus 1 is greater than equal to 0. And when will it come with a negative sign? When the quantity inside, that is x square minus 1, is negative, that is less than 0. And for that, we have tried to calculate the values of x. Now I know where to break the limits. How? See, for x less than equal to minus 1, the value of the function is x square minus 1. For the values of x from minus 1 to 1, the function is minus times of x square minus 1. And then again, when x is greater than equal to 1, the value would be x square minus 1. Now check the limits. We have limits from minus 2 to 4, which means that from the values, for the values of x minus 2 to 4, I want to integrate this function. But this function changes its expression in between minus 2 to 4. How? From minus 2 to minus 1, the function is x square minus 1. From minus 1 to 1, the function is minus times of x square minus 1. And for 1 to 4, the function is again x square minus 1. For all the values of x greater than equal to 1 or less than equal to minus 1, the function is x square minus 1. And for all the values of minus 1 to 1, the function is minus times of x square minus 1. You can solve this to get your final answer. I was interested up to this point only. You can easily solve this. We have done these questions a lot. We can directly solve this. Solving this part is not tough, but solving this question was tough, definitely tough. Because to solve this, first you need to define modulus. And after defining, break the function in appropriate way. Break the function in appropriate way. Anji, you understand this, everyone? Please feel free to ask me. कोई problem नहीं है, अभी पूछिए. अगर if you are facing a problem with this, please let's clear it now. By the way, we could have solved it using wavy curve. All of us know wavy curve. We could have also solved it using wavy curve. Okay. In that case, let's move on to the next question. You can complete the solution now after this point. Okay, let's come to third question. Yeah, let's solve this one. Okay. So, so the question is to integrate sine to the power 4x divided by sine to the power 4x plus cos to the power 4x dx from 0 to pi by 2. Okay. Now let's figure out which property we need to use, because that's the most important part, right? Now, in this case, the function is not piecewise. Definitely. There is no modulus. There is no greatest integer function. I mean, what are piecewise functions? Piecewise functions are either modulus or greatest integer function. These two will be the most used piecewise function in your syllabus. In fact, you won't even face greatest integer function most of the time. There will only be 1 or 2 questions on greatest integer function. Otherwise, the only used function or the only used piecewise function in your syllabus is modulus. So there is no modulus involved. So no use of third property, right? Now we have three properties: fourth, sixth, and eighth. Third will be used in piecewise. We don't know about fourth and sixth, and we also don't know about eighth, right? But the thing we know about eighth is eighth will only be used if the limits are from minus a to a. Minus a to a. There is no minus a to a here. It is from 0 to pi by 2. If the limits has been from minus pi by 2 to pi by 2, minus pi by 2 to pi by 2, then we would have thought about 8. But right now, there is no use of, I mean, there is no point of using eighth property, because that is only valid when the limits are from minus a to a. So eighth is not valid. Now remains fourth and sixth. In case of fourth and sixth, we will always go with the fourth first. What is fourth property? Fourth property says that if you are integrating a function from some limit a to b, then you can write the same function. You can write the same function by exchanging x with lower limit plus upper limit minus x, which is you can replace the x with pi by 2 minus x, and your answer will not change. Definitely will not change. Chalo, then start using fourth property now. And also, whenever in doubt, whenever you are not able to find out what should we do, always use fourth property. Okay. So in this case, we can replace, the limits will remain same. Your x will change, your x will change with pi by 2 minus x. So this becomes sine of pi by 2 minus x to the whole power 4 divided by sine of pi by 2 minus x to the whole power 4, and then again cos of pi by 2 minus x. Pi by 2 is 90, by the way. Hanji, can we solve sine 90 minus x? What is the value of sine 90 minus x? Anyone? What's the value of sine 90 minus x? Arre, इतना tough है. Austin, what is sine 90 minus x? Sine pi by 2 minus x. 10th class. We have studied this in 10th class. Tharif, what is sine? Okay. I got the answer, I guess. Yeah, correct, Austin. Sine 90 minus x is cos x. Tharif, what is cos 90 minus x? cos 90 minus x.
Sin x.
Correct, Shaviz. Sin x, right? So we know what is sin 90 minus x. We also know what is cos 90 minus x. Let's write it properly. So sin 90 minus x is cos x. So this is nothing but cos to the power 4, which is cos to the power 4x divided by, this is again cos to the power 4x. And this is sin power 4x. Let's write it as second equation. So we have our first equation, we have our second equation. Whenever we are using property 4, whenever we are using property 4, this will be the general norm, will be the general format. How to use property 4? Am I audible, guys?
Yes, sir.
Guys, am I audible? Okay, cool. So whenever we are using property 4, this will be our general format. Okay. We will always, whatever will be the question, we will always mark the question as equation 1. This will be used in all the questions where we have to use property. So write the question as first equation and then apply the property 4. Whatever you get, write that as second. And then add 1 and 2. Always add 1 and 2. So first property left hand side is I. Second property left hand side is also I. So this 2I come to right hand side. Right hand side here is pi by 2 limit, right? Here also 0 to pi limit. As long as the limits are same, you can add the two expressions. And in case the denominator is also same if you focus, right? Chalo. But I will write the proper expression for the first time because we are doing it for the first time. So this will be easier for you to understand. So this is my first expression and this is my second expression. And I told you that whenever your limits are same, you can always add the two expressions. Whenever your limits are same, you can always add the two expressions. So I can write this as a single expression from 0 to pi by 2. And I can add these two expressions. Now, while adding these two expressions, the denominator is also same. So it becomes very easy to add them. Just directly add the numerator. So this becomes sin to the power 4x plus cos to the power 4x divided by sin to the power 4x plus cos to the power 4x. This becomes cancelled out. This becomes 1. Now the integration of 1 is x from 0 to pi by 2. You put pi by 2 minus 0, so the answer is pi. But it is the answer 2i. You wanted to calculate what? I, not 2i. So I is what? Pi by 4. So while solving questions from fourth property, you will always follow this format. You write the question as first equation. You apply property 4. You simplify the expression. Whatever you get, write that as second equation. And add both of these equations. Your questions will become super easy. Chalo, let's solve one more question now. Uh, 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 uh. And first of all, please feel free to ask your doubts. जहां पे भी प्रॉब्लम है पूछ ले फटाफट से, कोई भी सोचने का ही नहीं है. Hmm. 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 Hanji, any idea how to what property should we apply here? Only focus on the properties. Let's identify the property. Which property we need to apply? Is it third? Is it third, guys? So is it eighth? Third तो हो ही नहीं सकता because this function is not piecewise. No? And then again, it can't be even eighth. Guys, am I audible? Hello, am I audible, guys?
Yes.
Okay, cool. So third cannot be used because the function is not piecewise. Eighth cannot be used because the limits are only remains fourth and sixth. And in case of fourth and sixth, I will always go with fourth first, then I will apply sixth. You will understand very less. That's important. ठीक. Then let's start. How can we replace x? 0 plus 2 minus x. Right? So replace x with 2 minus x. Okay, this is first equation. My second equation will be from 0 to 2. This x will become 2 minus x. And root will become 2 dx. Right? So this becomes 0 to 2, right? This is 2 minus x, right? And this is x. Enough. One thing is that we go and add 1 and 2. But you need to do this. Acha, before this, yeah, my integrate सबसे पहला अप्रोच फर्स्ट अप्रोच तो कैन वी इंटीग्रेट if we are able to integrate the given then we won't even think about properties. Integrate that question. If we are able to integrate the question using infinite integration, then we won't go to the properties. We will see. Guys, am I audible?
Yes.
So if we are able to integrate the function, then so I won't go. But you can see that I can't integrate the function directly in the, I mean, as the function is given to me. That is why I used property fourth. Right? But now I can integrate the function directly if you can see. Chavez, am I audible now? My internet connection is not good today, so that is why. But this is the last question. So am I audible now? Okay. So I could have I could not integrate the given question directly. Can't integrate directly. That is why I applied property, right? And after applying fourth property, now you can see that I can integrate this directly. So at any point, if I'm able to integrate the given question, I would not think anything else. I would just directly integrate that. So in this case, you apply with, you multiply root x with 2 root x minus this becomes x to the power 3 by 2, because this is x to the power 1 and this is x to the power half. So this becomes x to the power 3 by 2. And definitely I can easily integrate this function. How? This becomes 2 to the into x to the power half. So x to the power 3 by 2 divided by 3 by 2 minus this becomes x to the 5 by 2 divided by 5 by 2. We have it from 0 to 2. You can directly put the limits and get. So this is how we can apply these properties and how can they help us in the different scenarios. So both are the application of fourth property. The examples third and fourth both are the application of fourth property, but we can also use fourth property in two ways. One, we get the equation, we get the question as equation 1, we write the question as equation 1, and then we apply property 4, we get something, we add the two expressions, right? And second, when this property 4 to integrate the question, like in this example, in case we don't need to add them because this can be directly integrated now, right? And we will get the answer, whatever is the answer. You can solve. You can write x to the power 3 by 2 as x root x, and you can write x to the power 5 by 2 as x square root x, because 2 plus half is 5 by 2, right? So this will help you to get the final answer, because the final answer will be in terms of root 2, right? Chalo, we will meet on Wednesday and please start practicing these questions from 7 to 1. Your homework first, first 10. Okay. Chalo, we'll meet on Wednesday. Thank you.
Hello, Sharif, can you hear me?
Yes, I can hear you.
Okay, let us wait for 2-3 minutes more. Meanwhile, others may also join. So let us start now anyhow. So basically we have last class, what we did, Sharif, do you remember? Last class we had some gap also, like of 1 or 2 classes, I think.
Yes, sir.
So
I think,
anyone else took your class?
the last date was maximum minimum.
Sorry?
The last date was the maximum minimum applications of derivatives.
Okay. So as we decided, we will next class start integration. So in integration, do you remember the formula of indefinite integration, like simple formula x to the power n is x to the power n plus 1 by n plus 1
Plus C.
plus c. Okay. And what is the integral of sine x?
Sir, cos x.
Minus cos x.
Minus cos x plus C.
Yeah. So this simple integration we should need to remember. So I hope you remember these integrations, right?
Yes, sir.
Okay. So we can first do some simple questions based on them, like base substitution method, trigonometric identities and all. Like you can apply substitution method. So that will help us to solve. So our substitution method help us, like we have sine x by cos square x dx, and we have to integrate this. So what we do, we take cos x as t, and its derivative is minus sine x dx, which is dt. So we can say that denominator is t square and sine x dx is minus dt. So it will be minus dt by t square. And the dt by t square, you can write it as t to the power minus 2 dt. So this is minus, and integral will be t to the power minus 1 by minus 1 plus c. So it will be 1 by t plus c, which will be equal to, this is plus c, which is equal to 1 by cos x plus c. So this is how we use substitution method to solve them. Let's write this one.